So imagine that we have our input rectangle. Right now, normally, and what you could see is that it's saved as a couple of points, for example, in this order. And now if you want to place something over here, for example, I want to fill it up with a bunch of blanks. There's still a lot of stuff that I need to do to prepare or to just get it to this, because I would somehow need to then first convert it, for example, I could do a convert line and then select all the horizontal ones. So I just keep these two. Then I could resample those. Then with a special add attribute, I could kind of connect them again and then use those lines to place something. But it's more effort than I want it to be, especially because there's just so many different placement operations, and there's something to simplify this. So imagine we have our input facade, and what I want is to simplify this. So what I do is I convert this to a line. Then I have two up vectors and normals, which are going to kind of define this space for me. So I have a line, I have the 2 points at the bottom. Oh. And I will place 2 normals on those points. And I will also have 2 up vectors. So let's actually say that the normals are pointing outwards. And then let's use yellow, because that's what we did in Houdini as well. We have 2 up vectors going exactly to the end of this shape. So they also have the exact same length. Now I do have this line, which I can start resampling, and then I will also maintain all these up vectors. And placing stuff on this line and on those points and moving them is really, really easy. So that's the reason why I like to do this. So let's go back to Houdini and start making those lines. So what we want to do, first we have to decide do we want to keep the top line or the bottom line. Right now, because we use the terrain, I want to keep the top line and start pointing downwards, because that has the most clean feel that I can get right now. So our up vectors will actually start pointing downwards, which is fine, just a little bit counterintuitive. So we have our primitive over here, our primitive, oh, I think I did a reset over somewhere. There we go. All right, we have this one, and I'm going to do a convert line. Now, the next step is I'm going to place down a primitive wrangle, or let's do a normal node again, just to make sure that we have a healthy normal. We're doing primitive again and setting this to face area. And this is what we're going to be referencing. So I'm going to place a null and call this out. Oh. Out forward. And we have this convert line over here. All right, perfect. Right now it's kind of inconsistent what this order of primitives is. So we're going to be sorting them. As what I want to do is, I keep pressing that annoying button, which is a very handy shortcut for something else, but right now a little bit annoying. Oh, let's go back to scene view. There we go. And what I want to do is sort the primitives. And I want to be sorting them horizontally. So if we right now look at these primitives, you can see that we have 1 and 2 being in the middle and 0 and 3 at the top, which is nice. We don't need to out forward to do any sorting yet. But what I do want to do is to place a blast, because I just want to keep currently just for visual purposes 0 and 3. That's what I want to keep. Because we know we always have rectangles, so we always know how many lines there are, so we can just say 0 and 3, those are the ones we want to keep. Now, there's another thing. So right now I have a couple of points. What I want is that the point order of each of these separate lines is going from left to right. As you can see, whatever the direction is, and it's also kind of, again, where we need this forward direction. But we actually don't need the forward one, we need to have the side one. So if we place down a prim wrangle, we know how we can get this sideward direction. I can also visualize it for a bit. So right now you can see that it's pointing outwards. And right now I'm going to be calling it the normal. It's going to be equal to the cross product of the current normal and the up vector. There we go. And so this doesn't actually work that well. Let me visualize this in a little bit of a nicer way. And let's also check if something changed. Yes, so it did change, but we're not really seeing it right now, which is fine. I will just do this for the points, and then you can see it. Ah, perfect. So now we have a normal going sideways, which is exactly what we wanted, and that's also how it's saved on the primitive. Even though you cannot really see it, that's fine. We're just working in a little bit of a weird way. So let's go back to primitives, and now we have this forward attribute, which is basically the normal, saved on there. We're going to place down another sort. And in this sort we're going to have quite some settings to want to set. So one thing I would also advise you to get into the habit of is, if we want to reference another node, let's add a spare input, and then we just drag this out forward. So I now have a spare input added to this node, and I'm going to reference this node. So right now I want to sort the points along a vector, and the vector direction is this forward. So I'm going to be using prim to get a certain prim from a certain node. I can now type in -1 to reference the spare parameter. I can grab primitive number 0. I want to have the normal. And I need to have the first index. We can see that this is currently 1. We can check this. And yeah, that's correct. We want to have the normal, which is set to be 1. Because if we disable this one, it should have been -1 in the third one. So this is exactly correct. Now we can copy this over. And now we just need to change the index on the final two. Now we have a direction, and if we look at our sort, it should also visualize this direction with that arrow, which is perfectly pointing to the correct direction. Now, we should see that our points are ordered correctly, which is nice. Next up, we are going to split the two of these. So I want to have the lower and the upper one on one basically split. And instead of using two blasts, I can actually use the split node to lower this node count a little bit. Well, I'm not actually lowering the node count, because a split is basically two blasts. And now I have two lines going both directions, and I'm going to place a point wrangle. Because both of these lines have 0 and 1, and the reason why I did this sort was just to really force that both of these lines are basically the same, but then one is higher than the other. Because if the point numbers of these were to be reversed, this would have been a little bit annoying. That sometimes happens depending on exactly what your system is doing and how the Voronoi is operating. So just to make sure that those are linked, we can now have basically run over these points by having a kind of a ghost copy going into the second input. as what we want to do. If we want to have this forward normal, which we still have, which is fine, we now basically want to set the up, which we know the direction of the up, but we want it to also have the length, which is very important. And let's reverse this one actually, because we want to go from the top and we want to point downwards. So how do we get this this number, this direction with the correct length? That's very doable. What we do is we grab the current position. So we make a vector, pulse from position A, which is equal to V and P. And we also want this from the second point, which is the ghost copy, which we can get by declaring it number position B, which is going to be equal to point. The position is what we want to grab, and we use E at ptnum to use the current point number, which in this case is 0 or is 1, and to grab basically the position of our ghost copy. Now, next up, what we want to do is to set the up vector. And that's going to be equal to basically the two of these positions negated from each other. So don't forget the equals. Position A minus position B. And this order basically determines the direction. So let's visualize our up vector again. And right now I see that I don't really have an up vector. So let's see what I typed in incorrectly over here. Let's set the position B. So let's see if we can right now move our position to whatever is the second input, just to check if this is correct. So we have this and nothing is moving. So I see what I did wrong. So what we can see right now is that I grabbed the current position basically instead of the second input, which I needed to write a 1 to grab the second input. And you can see we have our up vectors going upwards. And to reverse that, we need to do this in reverse, pulse B minus pulse A. Perfect. So now if we look at our input primitive, we currently have a very nice solution for this. The one thing we're missing is the forward normal, because this convert line, I think, removed it, if I'm correct. Let me check. Yes, I think the convert line did this. But let's just double check. Oh, no, I see my normals. I was just blind. Okay. So I did kind of lose them. Let's just do an attribute copy to get them again. We should have got, still have them over here. And let's make sure this is the normal. They are always the same because we don't really have any bent corners or anything. So, and let's make sure that we actually have them, because they might not have been on the points. Could also have been the issue. But right now we have our normals and our up vector, and we have the two pencils basically sticking inside of the apple, which will allow us to play stuff with full control. Not for all placement you will need that, but it's nice to always have the option for complete control. Alright, so we're going to repeat this a little bit, because for this one right now is doing this for all of these points. And the reason why we group them together like this is because we can right now kind of combine them, because right now we just have too many loose primitives. So what we can do is a path node, a polypath, to clean this up again. And let's also do a fuse. With this fuse we're going to get rid of these kind of slivers that we got from the previous Voronoi. And we do not want to update the normals, which is a setting over here. And right now we have also placed the polypath, and you should have seen, yes, you can see that we only have one primitive. A little bit hard to see, but we have one primitive on the top and one on the bottom instead of all those separate ones, which is pretty nice. This top one is actually very similar, so you could do an algorithm which also gets like those inline points and removes them, because they don't really add any interesting detail. Sometimes they do, sometimes they don't. But here at the bottom we can have a height difference because there's terrain over here, which is kind of cool. Let's wire this in and make sure that we're doing this for everything by disabling single pass. And you can see that we have this sort of placement segments for our entire building, including normals, which are linked to the terrain, which is pretty cool. So this was the segmentize phase of the building creation. And now the most creative part comes, where it mainly also becomes an exercise for the student, but I'll show you some tricks, what you can do with this, but you can do a lot more, and yeah, just play around with it. You can do a lot of stuff with this kind of setup. So let's dive into the next segment, actually using these vectors to start placing stuff.